Good evening everyone, good evening. Welcome you all again to your Vedantu and Enlite channel. I hope all of you are doing great, having a good time. So people, quickly let me know in the chats if I'm perfectly audible and visible to everyone. Yes. Hello Senthil, hi Chaundarya, hello Chan, hi Yogesh, hello MJ. Welcome back, hello Antara. Welcome back, hello ATL. Let me quickly know in the chats, people, if I'm perfectly audible and visible to everyone. Yes, give me some green signal from the chats. Give me some green signal from the chats so that I'll get to know that I'm perfectly audible and visible to every one of you. All right, people, just give me a second. I'll just fix the things, then we'll be starting, right? Just give me a second. Alright people, so as you all must be knowing, this session is particularly for the ones who are going to write the CBSE Term 2 examination after just 2 days, right? What all things I'm going to cover in this particular session, I'm going to give you the short questions from 3 chapters of your physical chemistry. One is your electrochemistry, followed by kinetics, followed by surface chemistry, right? So in this particular session, 3 chapters will be done. Short questions from 3 chapters I'll be doing. And tomorrow, I'm going to give you again the short questions of your complete chemistry term 2 syllabus, right? So tomorrow is one more session, one more short session as far as your CBSE term 2 chemistry portion is concerned, right? And before starting this particular session, my dear people, the ones who have just joined in, the ones who are new to the channel, I'll just quickly introduce myself. So people, my name is Wassim and I'm your chemistry master tutor right here on this Vedantu and Enlite channel, right? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this Vedantu and Enlite channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well, right? Perfect. So let me quickly know in the chats if all of you are super duper excited about this particular session as well, my dear people. Yes. Let me quickly know in the chats if all of you are super duper excited about this particular session as well. Let me see the josh of this particular session. Yeah. Someone is asking, sir, will this come surely? Well, the type of the question is going to be the same. Whatever questions, whatever different types of questions, different patterns of questions I'm going to show you, right? You can expect the similar type of question in your examination. I won't say these questions will directly come, or they might come the way it came in term 1 examination, right? These questions, I mean, they can also come, or the questions of the similar type can come in your examination, right? So before starting this particular session, let me quickly know, people, if you all are super duper excited about this session. Yes? Perfect, guys. Perfect. So let's get going then. Let's get started with the chapter Electrochemistry. Let me give you some really important questions from the chapter Electrochemistry, right? Which you call as the short questions. Perfect. So let's get going then. Let's get started with the first question, which is on your screen. This is the question on your screen, my dear people. Have a look exactly what the question says. These are the different types of questions which have been asked, which can be asked from galvanic cell, which you call as Daniell cell basically, right? What is the direction of flow of electrons in the Daniell cell? Which one is anode and which one is cathode? What will happen if salt bridge is removed? How will concentration of Zn dye positive and Cu dye positive ions be affected when the cell functions? How will concentration of these ions be affected when the cell becomes dead, right? These are the different types of questions which can be asked. Perfect. Have a look, people. First thing, in your Daniell cell, I'm sure you all must be familiar with the fact, in your Daniell cell, we use 2 electrodes. One is zinc electrode and another one is copper electrode. Zinc electrode, it behaves like the anode. Copper electrode, it behaves like the cathode. You guys must be knowing this, right? Well, the first point is done. Second point, what is the direction of flow of electrons? If I talk about the direction of flow of electrons in your Daniell cell, the flow of electrons will be from anode to cathode, right? What about the direction of current? The direction of current is just reverse to it. It's going to be from cathode to anode. right? What will happen if salt bridge is removed? Let me tell you, if I talk about the salt bridge, it is used to complete the internal circuit. It is used to complete, its first function is to complete the internal circuit, right? If salt bridge is removed, no current will be drawn from the cell. The cell will not work, I must say, right? If salt bridge is removed, no current will be drawn from the cell, right? How will the concentration of these ions be affected when the cell becomes dead, right? These are the simple questions, my dear people, which can be asked from the Daniel cell, right? And look at this particular question. How will the concentration of Zn dye positive and Cu dye positive ions be affected when the cell functions? So basically, when the cell starts working, the concentration of Zn dye positive in the left container, it starts to increase, and the concentration of Cu dye positive in the right container, it starts to decrease. Do remember it, right? And how will the concentration of these ions be affected when the cell becomes dead? Nothing happens to the concentration of these ions when the cell becomes dead, right? So how you are going to write it in the examination, the way I told you exactly, that's how you are going to write it in your examination, right? All these points can be asked in your upcoming examination, right? This was the first question, my dear people. I'm sure every one of you are clear with these 5 points, right? Perfect. Look at this particular question, my dear people. Have a look. On the basis of E naught values, identify which one of the following is the strongest oxidizing agent. First of all, oxidizing agent is the one which oxidizes others but itself undergoes reduction. So oxidizing agent itself undergoes reduction, right? Let me tell you, that element which has got the highest standard reduction potential will undergo reduction easily, will be the better oxidizing agent, right? The one which will be having maximum standard reduction potential will undergo reduction easily, will be the better oxidizing agent. Now, first of all, let's have a look which among all has got the highest standard reduction potential. If you look at all the reactions, my dear people, in every reaction, electrons are being gained, right? Gain of electrons is something which we call as reduction. So in the first reaction, you must say Cl2 undergoes reduction. In the second reaction, MnO4 negative undergoes reduction. And over here, Cr2O7 di negative, it undergoes reduction, right? And these are the standard reduction potential values which are given to me. Check which one has got the maximum standard reduction potential value. This value is the maximum among all. So I must say MnO4 negative, it has got the maximum standard reduction potential value. And the one which will be having maximum standard reduction potential value, it will undergo reduction easily. It will be the better oxidizing agent. So which one among the following is the better oxidizing agent, is the strong oxidizing agent? It's absolutely going to be MnO4 negative, which is the strong oxidizing agent among all. You guys can let me know in the chats if it is clear to everyone. Yes, people? Let me quickly know in the chats if it is clear to everyone. Perfect. Guys, it's not Mn di positive. Mn di positive does not undergo reduction here. It is MnO4 negative which is undergoing reduction. Basically, it is gaining electrons, right? The one which gains electrons, that undergoes reduction. That is the point. Okay, it's not Mn di positive. Be careful with it. It's MnO4 negative. I'm sure this sort of a question you can easily solve, right? Calculate the EMF of the cell. I'm supposed to calculate EMF of the given cell, right? So how do we calculate EMF of the cell, my dear people? For that purpose, we use the Nernst equation. I'm sure you know that, right? So I'll be using Nernst equation in this question. First thing, these are the two lines which represent your salt bridge. On the left-hand side of the salt bridge, we always write the anode, right? And on the right-hand side of the salt bridge, we always write the cathode, yeah? At anode, oxidation takes place. At cathode, reduction takes place. So first thing, I will be writing the reaction which will be taking place at anode. You guys know at anode, oxidation takes place. Tin gets converted into Sn di positive. So reaction is going to be Sn solid. It gives Sn di positive aqueous plus how many electrons? Plus it's going to give 2 electrons, right? This is the reaction which will be taking place at anode. Similarly, if I ask you what is the reaction which will be taking place at cathode, you know, at cathode reduction takes place. Reduction means gain of electrons. So Pb di positive is getting converted into Pb solid. So the reaction is supposed to be like this. Pb di positive aqueous plus 2 electrons gets converted into Pb solid. This is the reaction taking place at cathode, right? Well, in both the reactions, electrons are balanced, so I can directly add the two reactions, right? If the electrons were not balanced at that point of time, I was supposed to balance the electrons first, right? But in both the reactions, electrons are given in the balanced form, right? So I'll be directly adding the two. When I add the two, the net cell reaction becomes like this: tin solid plus Pb dye positive aqueous. It gives Sn dye positive aqueous plus Pb solid. This is the reaction, this is the net cell reaction which takes place over here, right? Now people, if I ask you how many electrons got exchanged, you'll say 2 moles of electrons got exchanged in the net cell reaction. So N value is 2. 2 moles of electrons got exchanged. Well, after that, if I want you guys to calculate the QC, reaction quotient, how do you calculate the reaction quotient? How do you write the expression for reaction quotient? You write the expression of reaction quotient in the similar way as you write the expression for equilibrium constant, right? See, that reactant or product which is going to be in pure solid form, its active mass will be taken as 1 unity. So I've got nothing to do with this tin, I've got nothing to do with this lead, because both are in solid form. Any species which will be in aqueous form, you'll be using the term concentration for them. Starting with Sn dye positive, I'll be writing concentration of Sn dye positive, raised power stoichiometric coefficient, that's 1, divided by concentration of Pb dye positive, raised power stoichiometric coefficient, that's 1. Have a look at the equation. The concentration of Sn dye positive is given to me as 1, divided by concentration of Pb dye positive is given to me as 10 raised power minus 3. So the overall value comes out to be 10 raised power 3. So this is the QC value which you got, right? Well, after getting the QC value, I would want you guys to calculate the E0 cell as well, which you call as standard EMF. It is simply going to be equal to E0 of cathode minus E0 of anode. And do remember, when you use this expression, when you need to calculate E0 cell, over here you'll be taking the standard reduction potential value of cathode, and over here you'll be again taking the standard reduction potential value of anode, right? So E0 cell comes out to be E0 of cathode, standard reduction potential of cathode. Since lead electrode is your cathode, and this is the standard reduction potential of cathode which is given to me, that's minus 0.13, minus standard reduction potential of anode. This tin is your anode, and this is the standard reduction potential of anode which is given to me, minus 0.14. When you solve it, you get the value 0.01. Is that 0.01 volts? This is the E0 cell. Since you calculated E0 cell as well, now I'm supposed to calculate E cell as per the equation. So for that purpose, I'll be using the Nernst equation. E cell is equal to E0 cell minus 0.0591 divided by N. It's going to be log of QC. This is the expression which we'll be using. So E cell comes out to be E0 cell, that comes out to be 0.01 minus 0.0591 divided by N value is 2. Log of QC value is simply 10 raised power 3. Is that? Yes, we have calculated that, 10 raised power 3. So I can write it simply like this: 0.01 minus 0.0591 divided by 2. It's log of m raised power n, which comes out to be n log m. So 3 comes to the front, then comes log of 10. And this log of 10 value is equal to 1. You guys know it. So it's going to be your job to do this much of calculation now and get the answer, right? This is the final answer in volts, which is basically the E cell which I was supposed to calculate, right? So what is the final answer which you are getting? Let me show it to you. Well, after doing this bit of calculation, the final answer which you will be getting, that's going to be minus 0.07 volts. This is the correct answer of this particular question, my dear people. I'm sure this is clear to everyone and you are remembering how to tackle this sort of a question, right? And if you have not liked the video yet, please do like the video, share the video with your friends, and do subscribe to the channel as well, right? Perfect, people. Should I move on? Let me know in the chats if it is super clear to everyone. Perfect, guys. Let me move on to one more then. This is one more question. Let's exactly get to know how to solve this sort of equation. Very simpler one. First thing, you are given with a net cell reaction which is involved in some galvanic cell, right? You are given with a net cell reaction which happens in some galvanic cell, right? So first thing, you are supposed to represent this cell, right? And how do you represent it? Have a look. Chromium, its oxidation state is 0. Iron, the charge on it is +2, so its oxidation state is +2. Chromium, the charge on it is +3, so its oxidation state right here is +3. And over here it's 0, right? Now first of all, for chromium, the oxidation state is increasing from 0 to +3. And for iron, the oxidation state is decreasing from +2 to 0. You guys know, increase in the oxidation state is what we call as oxidation, and decrease in the oxidation state is what we call as reduction. So I must say this chromium undergoes oxidation and this Fe di positive undergoes reduction, right? So how am I going to represent it? First of all, I'll be using two lines which represent the salt bridge, and on the left hand side of the salt bridge you always write the anode, and at anode oxidation takes place. And what is happening during oxidation? During oxidation your chromium solid is getting converted into Cr tri positive aqueous, right? This is your anode. On the right hand side you'll be writing the cathode. At cathode reduction takes place and Fe di positive is undergoing reduction, right? And Fe di positive aqueous after undergoing reduction gets converted into Fe solid. So this is how you represented the cell whose net cell reaction was given to us, right? This is how you represented a cell whose net cell reaction was given to us. I'm sure it's clear. So first part of the question is done and dusted. What does the second part say? Calculate E naught cell. E naught cell, as I told you a few minutes back, it's nothing, it's E naught of cathode minus E naught of anode. What is E naught of cathode basically? It is basically the standard reduction potential of cathode. And this is standard reduction potential of anode, right? So your cathode is the chromium electrode. Your anode is the chromium electrode. So this iron is your cathode, right? This is your cathode and this is your anode. So I need the standard reduction potential of cathode first. So I need the standard reduction potential of iron first. Have a look. Is this standard reduction potential of iron or standard oxidation potential? Check it out. How do you check it exactly? Have a look. Plus 2 to 0. Plus 2 to 0. Decrease in the oxidation state. Decrease in the oxidation state means reduction. Reduction, right? So this is the standard reduction potential. So it's minus 0.44. This is the standard reduction potential of your cathode. Minus standard reduction potential of your anode. This is your standard reduction potential of anode, which is minus 0.74, right? So can you let me know in the chats how much this value comes out to be exactly? 0.3, all right. So 0.3 volts is basically the E naught cell which I calculated and was supposed to calculate, right? Shashank, these are the same questions. These are the same questions. Perfect. Perfect, people. I'm sure this is clear to everyone again. So let's move on and have a look on a few more questions. Look at this particular question. Again, this is the similar sort of question. Cell is given to you. The net cell reaction is given to you. Number one. E naught cell is also given to you, right? You need to calculate E cell. The similar procedure you guys will be doing, which I showed you just now. Have a look. First of all, this is the cell reaction which is given to me, right? E naught cell is given to me. N value you can calculate as 6 and log of QC. This is the QC value. Okay, and finally you get the answer as 1.269 volts, right? So this is the similar sort of question. That's why I did not show it to you, right? It is the similar sort of question which I showed you a few minutes back. Okay, have a look on this one. Look here, people. If you look at this particular question, these two lines, they represent your salt bridge, right? On the left hand side of the salt bridge, this is the silver electrode you are using. Right hand side, again the silver electrode. Whenever in a cell you use two same electrodes, you call that cell as the concentration cell. And do remember, for the concentration cells, what do we say? We say E naught cell value is 0. For the concentration cells, E naught cell is equal to 0, right? First thing, calculate the EMF of the cell at 25 degrees centigrade, number one. Write the net cell reaction, right? Will the cell generate EMF when the two concentrations become equal? Have a look, people. How am I going to solve this question? First of all, this is your anode, right? So what happens at anode, you guys know it. At anode, oxidation takes place. Basically, your Ag solid, it will be getting converted into Ag positive. This is Ag positive here. Ag positive, whose concentration is 0.01 molar plus 1 electron. This is the reaction which will be taking place at anode, right? Similarly, my dear people, the reaction which will be taking place at cathode, let's have a look on that. At cathode, reduction takes place. So Ag positive gets converted into Ag solid. So I must say, the reaction at cathode, Ag positive, whose concentration was 1 molar, it will be getting 1 electron, getting converted into Ag solid. This is the reaction taking place at cathode. Now, people, are the electrons balanced in both the reactions? Yes. So I can directly add them up. When I add these two reactions up, this Ag solid gets cancelled out, 1 gets cancelled out. So my net reaction becomes Ag positive with the concentration 1 molar. It gives Ag positive with a concentration 0.01 molar, right? This is my net cell reaction. If I ask you what is the value of N for this particular reaction, since one electron got cancelled over here, so I'll say the number of moles of electrons which gets exchanged in the net cell reaction, that's exactly 1. N value you got to know as 1, right? After getting the N value, E naught cell you already know, I'll be writing the expression for QC. How do I write the expression for QC? I'll write this concentration, which is 0.01, divided by concentration of this Ag positive, that's 1. The value exactly comes out to be 10 raised per minus 2. Why did I not use the stoichiometric coefficients over here? Because the stoichiometric coefficients over here in both the ones is 1, right? Yes? Perfect, guys. Is it clear till here? Let me know. Perfect. Alright, so every parameter you got, which is needed for the Nernst equation. So I can simply calculate E cell as per the Nernst equation. E cell is equal to E naught cell, that's 0, minus 0.0591, divided by N, which is 1. Log of QC. QC value is simply 10 raised per minus 2. Is that? Yes. So from here, you'll be calculating E cell, which comes out to be minus 0.0591. Log of M raised per N comes out to be N log of M. N log of M. And log 10, you guys know that's 1, right? So this is going to be your E cell value, which comes out to be plus 0.01 volts around that, right? Something like that. So that's the final answer of the question. Sorry, it's not 0.01, it's 0.1, right? 0.118 volts. Perfect. This is the EMF of the cell which I was supposed to calculate. So you have calculated the EMF, number 1. Number 2, write the net cell reaction. This is the net cell reaction which we have written. Number 3, will the cell generate EMF when the concentrations become equal? If the concentrations become equal, if the concentration becomes equal, right? QC value at that point of time comes out to be 1, right? If these concentrations, if concentration of both these Ag positives becomes equal, at that point of time, I can say QC value will come out to be 1. And when QC comes out to be 1, log of 1 becomes 0. And when log of 1 becomes 0, this whole term becomes 0. This whole term becoming 0 means E cell value is 0. And when E cell becomes 0, there will be no EMF in the cell. If there is no EMF, if there is no potential difference in the cell will not work, right? Perfect. Is it clear to everyone? Let me know in the chats. Absolutely, guys. Moving on to one more. Similar sort of question. This is something which I'm not going to do. This is something which you guys are going to do on your own, right? Same, similar sort of question which I showed you just now, right? And let me show you its solution simple. So first of all, after writing the reaction at anode, after writing the reaction at cathode, you'll be writing the net cell reaction. This is the net cell reaction, right? Then you'll be using the Nernst equation. E cell is equal to E naught cell. E naught cell you can calculate by the formula E naught of cathode minus E naught of anode. Both the values are given to us. N value you can calculate simply, right? You know it. Log of QC. QC, every parameter is given. So final answer comes out to be 0.41, right? This is the similar sort of question which I expect you guys to solve, right? Perfect. Calculate the potential of the hydrogen electrode. So first thing, whenever this sort of a question comes in the examination, calculate the potential of the electrode. So do remember, he's asking about reduction potential. Whenever only potential comes out to be, that means he's asking about reduction potential. Calculate the reduction potential of hydrogen electrode. See, I can calculate the reduction potential of hydrogen electrode, but how? I'll make sure the hydrogen electrode behaves like the cathode, right? Then only reduction will take place there, right? And when hydrogen electrode behaves like the cathode, what is the reaction which will be taking place at hydrogen electrode? It's simple, 2 times H positive plus 2 electrons gives H2 gas. This is the reaction which will be taking place when the hydrogen electrode behaves like the cathode, right? Every one of you will be knowing this. This is the reduction reaction which takes place when hydrogen electrode behaves like the cathode, right? Now people, have a look. Calculate the potential of the hydrogen electrode which is in contact with the solution whose pH is 10, alright? See, first thing, how many moles of electrons got exchanged in the net cell reaction? It's 2, so N value I got to know is 2, number 1. Number 2, if I want to write the QC expression, we can do that. This is in gaseous form, I'll be writing partial pressure of H2, right? Raised by stoichiometric coefficient, that's 1. Divided by concentration of H positive, raised by stoichiometric coefficient, that's 2, right? Now people, let me tell you one thing. Whenever the partial pressure of H2 won't be given, you'll be assuming the partial pressure of H2 is 1 bar, right? Divided by concentration of H positive raised by 2, and this comes out to be H positive concentration raised by minus 2. Yeah? Simple. Now we will have a look exactly. QC you calculated. If I ask you, what about the standard reduction potential of the hydrogen electrode? See, hydrogen electrode is the reference. Its standard reduction potential as well as standard oxidation potential is taken as 0. That's something which every one of you will be knowing, right? Now I'll be using the Nernst equation. I'll be writing reduction potential of the electrode is equal to standard reduction potential, that's 0 minus 0.0591 divided by N, and it's going to be log of QC. This is how you're going to write the reduction potential expression. So I must say reduction potential of the hydrogen electrode is equal to minus 0.0591 divided by N. N value is 2 and log of QC. QC value we got to know as H positive concentration raised to the power minus 2. Now a bit of calculation is needed. 0.0591 divided by 2. It is log of M raised power N, which comes out to be N log M. So minus 2 comes to the front. It's going to be log of H positive concentration, right? So this 2 and this 2 gets cancelled over here. So it becomes 0.0591 multiplied by minus log of H positive. That's something everyone must be doing. Minus log of H positive stands for pH, right? And people, as per the question, just have a look exactly. Is the pH given to us? Is the pH of the solution in which the hydrogen rod is dipped given to us? Absolutely. pH of the solution is given to us as 10. So multiply this term by 10 and get the answer exactly in volts. This is going to be the reduction potential of the hydrogen electrode, which we were supposed to calculate. Let me quickly know in the chats if it is super clear to everyone. Let me quickly know, my dear people, in the chats if it is super clear to everyone. It has to be clear, right? Okay, this is one more question. When acidulated water, when dilute H2SO4 solution is electrolyzed, will the pH of the solution be affected? What do you think? What do you think, my dear people? When the dilute H2SO4 undergoes electrolysis, will the pH of the solution change? It's not going to change. Why is that? Because when the dilute H2SO4 undergoes electrolysis, this is the reaction which takes place at anode. This is the reaction which takes place at cathode, right? These are the two reactions which are going to happen. See, at anode 4 moles of H positive are liberated and at cathode 4 moles of H positive are consumed. So whatever H positive is liberated, same amount of H positive is consumed. So eventually no increase, no net increase in the H positives. If there is no net increase in the H positive, there'll be no change in the pH. So pH remains unaffected, right? Clear to everyone? Absolutely, it's not going to change at all. Let me move on to one more question. Calculate delta G naught and log of Kc. What is Kc over here? Kc is the equilibrium constant. So I need to calculate log of equilibrium constant. See, I can only calculate log of equilibrium constant if I assume the cell is at equilibrium. If I assume this cell is at equilibrium, then only I can use the term equilibrium constant. So I'm assuming this cell is at equilibrium. And do remember, when the cell is at equilibrium, E cell value is equal to 0. Right? When the cell is at equilibrium, no current is drawn from the cell. Right? The potential difference between the electrodes, it becomes 0. Right? Now we will have a look. What do I need to calculate? I need to calculate delta G naught. So first thing which I'll be doing over here, I will be calculating E naught cell first. I will be calculating E naught cell. And E naught cell, do remember, it's nothing. It is E naught of cathode minus E naught of anode. Which one is cathode over here? Say, cadmium is undergoing reduction. Zinc is undergoing oxidation. Reduction takes place at cathode, right? So cadmium is your cathode over here. So E naught of cathode is given to me as 0.403 minus E naught of anode is given to me as minus 0.763. Let me know in the chats how much this value exactly comes out to be. Fast people, let me know in the chats how much this value comes out to be exactly. Let me know in the chats fast. I'm waiting. 0.36 is that? So 0.36 people are saying. So E naught cell you calculated 0.36. Well, after calculating E naught cell, now I'll be using the term delta G naught. Delta G naught is basically equal to minus NF E naught cell, right? So people, what is the value of N? How many moles of electrons got exchanged in the net cell reaction? You can check it out. It's 2, right? 2 moles of electrons got exchanged in the net cell reaction. Check it out. Cadmium dipositive is gaining 2 moles of electrons, right? And zinc is losing 2 moles of electrons. So basically 2 moles of electrons have been exchanged. Faraday's constant, you guys know, it's 96500 coulombs. E naught cell you got to know 0.36, right? Every parameter you used as per SI system, that means delta G naught value will come as per SI system. But if you want the answer in kilojoules, then divide the same thing with 1000, then the answer will come out to be in kilojoules. I hope that's clear, right? Perfect. So delta G naught you calculated, right? Now people, what do you need to calculate? You need to calculate log of QC. See, now I'll be using the Nernst equation. As per Nernst equation, since E cell is 0, so I'll say E naught cell is equal to 0.0591 divided by N, and it's going to be log of Kc because the cell is at equilibrium, right? So from here, you can calculate log Kc value. I must say log Kc is equal to this multiplied by this divided by this. It's going to be E naught cell multiplied by N divided by 0.0591. Check it out, people. E naught cell is given to us. I mean, we have calculated the E naught cell. That is 0.36. N value, you guys know, that's 2. Divided by 0.0591. Just solve this value. That's going to give you the log of Kc exactly, right? Let me quickly know in the chats if it's clear to everyone. Let me quickly know in the chats, people, if it's clear to everyone. So that's how you are doing it exactly, and log Kc finally comes out to be 12.18. Yeah? Yes, Selva, you're absolutely right. Perfect. This is one more question, my dear people, and this is the similar sort of question. You guys can solve it on your own, I'm sure. Calculate the EMF. You need to calculate EMF, right? After calculating EMF, you need to calculate delta G naught as well. The similar sort of question. First of all, calculate the standard EMF. Calculate E naught cell first. E naught of cathode minus E naught of anode. All the parameters are given to us. E naught cell you'll be calculating. N value you'll be calculating. QC value you'll be calculating, right? Then you'll be using the Nernst equation. You'll be getting EMF from there, right? You'll be calculating the EMF from there. And once you get the EMF, you can easily calculate delta G naught already, right? That's minus NF E naught cell. E naught cell already you have calculated, and delta G naught will come on its own. The similar sort of question which we have solved till now, right? So I'm not going to do it. You guys are going to do it on its own, right? Look at this particular question, guys. What do you think about this one? You can expect these sort of questions in your examination. The molar conductivity of a 1.5 molar solution of electrolyte is found to be molar conductivity, right? Lambda m is given to us as 138.9. This is Siemens centimeter square per mole. This is something which is given to me as per the question. Molarity of the solution is also given to me. How much it is? 1.5, right? And people calculate the conductivity of the solution. We need to get the value of kappa. Conductivity is something we need to calculate. It's a really formula-based question. You guys can kill it, I'm sure. You can say lambda m is basically equal to kappa multiplied by 1000 divided by m. This is the formula if you want to calculate lambda m in Siemens centimeter square per mole. This is the relation which you will be using, right? Okay, and do remember, if you want to use the same formula, but if you want to get the results in Siemens meter square per mole, if you want to get the results in Siemens meter square per mole, then the formula gets changed. It becomes K divided by 1000 multiplied by m. But in this particular question, I'm not going to use this particular formula because this is something which I'll be using when the units are given in Siemens meter square per mole, right? So I'll be using this particular result over here. Now check it out. Lambda m is given to us as per the question, 138.9, right? Is equal to kappa I need to calculate, multiplied by what? 1000 divided by molarity, how much it's given? 1.5. So kappa value from here you can easily calculate in Siemens centimeter inverse, right? Isn't it simple and basic, my dear people? Tushar, this is the English channel. That's why I'm not talking Hindi. If you want to see my Hindi lectures, you can go to Vedantu NEET Made Easy channel. I teach in Hindi there, right? Perfect, people? All right, I'm moving on to one more. Look at this particular one. Which of the two offers less resistance to the flow of current? I'm sure you guys know resistance is equal to, or let me write it like this, conductivity kappa is equal to 1 divided by R multiplied by L by A. This is something which every one of you will be knowing, right? Yes. So kappa is basically inversely proportional to resistance, right? More the value of K, lesser the value of resistance. Now which one has got more value of K? This is the max more value of K out of these two. More the value of K, more the value of K, lesser the resistance. So this solution, which is solution A has got more kappa value, so it will be having less resistance. It will be showing less resistance, whereas B has got more kappa value. B has got less kappa value, so its resistance will be higher. That's something which you were supposed to check. That's it. I'm sure it's clear. One more similar sort of question, my dear people. The electrical resistance of a column of 0.05 molar NaOH solution of diameter 1 centimeter and length 50 centimeters is 5.5. See, the resistance of the solution is given to us. Resistance of the solution is given to us as 5.5 into 10 raised to the power of 3 ohm. This is something which is given to us as per the question, right? Calculate the resistivity. conductivity and molar conductivity. It's simple, guys. See, every single parameter is given to us. See, L value is given to us. L value is given to us. Diameter is given to us. So we can calculate area of cross section by the formula pi r square, right? You can calculate area of cross section. Why do I need area of cross section? Because I might need cell constant L by A. L is given, A I'll calculate from there. So let me show you the solution exactly. So first of all, we'll be calculating the area of cross section pi r square. This is the area of cross section, right? Rho, that is resistivity, which I need to calculate, is equal to R A divided by L. R is the resistance given to me. Area of cross section, I calculated. Length, the distance between the electrodes, that's 50 centimeter given to me. So from here you can calculate the resistivity. After getting the resistivity, you know, conductivity is basically inverse of resistivity. So 1 by resistivity. So 1 by this particular value will give you the conductivity. And after getting the conductivity, you can easily calculate lambda m as well, molar conductivity, which is equal to kappa multiplied with 1000 by m. Kappa conductivity you calculated, multiplied with 1000, divided by molarity. Every single thing, all the formula based questions these are, and I'm sure this is going to be clear to everyone. Perfect. Right, people? Let me know in the chats if every single thing is clear till here. What about this particular question? Calculate the degree of dissociation of acetic acid. We need to calculate alpha for acetic acid. Well, there is one result. Alpha for a weak electrolyte is always equal to molar conductivity at a given concentration divided by molar conductivity at infinite dilution, right? What is molar conductivity of CH3COH, which is given to us? Molar conductivity of CH3COH, which is given to us, 39.05, divided by molar conductivity of same CH3COH at infinite dilution. That's something which I'll be calculating. Molar conductivity of CH3COH at infinite dilution is simply going to be lambda naught of CH3CO negative plus lambda naught of H positive. Lambda naught of CH3CO negative is given to us. It's 349.6 plus 40.9. Just add them up. What is the value which will be coming out to be? It will come out to be 390 around. It will be coming out to be 390.5, right? 390.5. So this is lambda naught value, which comes out to be 390.5. Since lambda naught m you calculated 390.5, so the overall value comes out to be 10 raised power minus 1. This is the alpha, which I was supposed to calculate 0.1. Right? I'm sure you can easily solve this sort of question again. Right, people? This was again very, very simple question, which is clear. Right? So these were the most expected questions from the chapter Electrochemistry. Right? Now let's move on to the questions of chemical kinetics. The first question on your screen, my dear people. Have a look. If the concentration of H2O2 changes from 0.5 molar to 0.05 molar in 15 seconds, then calculate rate of reaction. Second, rate of appearance of O2. Correct? So first thing, this is the balanced chemical equation which I'm given with. So let me write the differential form of rate for this particular equation. I'll be starting with minus sign, then I'll be writing change in the concentration of H2O2 divided by dt. This term gives me the rate of reaction in terms of H2O2. In terms of water, since water is the product, I'll be starting with the positive sign. It's going to be d of H2O divided by dt, right? Because the stoichiometric coefficient is 1. In terms of O2, I'll be using the plus sign. 1 divided by stoichiometric coefficient is 1 by 2. It's going to be d of O2 divided by what? d of O2 divided by dt, right? That's how you're going to write the differential form of rate. Perfect. Now, what do I need to calculate first of all? I need to calculate rate of reaction. See guys, you can calculate rate of reaction by solving any of these terms. Let me take this term out. Why am I taking this term out? Because the data for H2O2 is given to us. The data for H2O2 is given to us. I can write rate of reaction is equal to minus times d of H2O2. Change in the concentration of H2O2, which is basically final concentration of H2O2 0.05 minus initial concentration of H2O2, that's 0.5. Divided by dt, that's the time interval, 15 seconds. You can solve it, get the answer in moles, liter inverse, second inverse. This is the first part of the question. The second part of the question, calculate the rate of appearance of O2. How do we represent rate of appearance of O2? Rate of appearance of O2 mathematically is represented something like this. This is something which I need to calculate basically. This is something I need to calculate, rate of appearance of O2. Now people have a look. From this particular equation which we have already made, I'm again going to take two terms. One is this term and one is this term, right? I'm going to equate these two terms. When I equate these two terms, I'll be writing something like this. Minus d of H2O2 divided by dt is equal. This 2 comes up. It comes out to be plus 2 times d of O2 divided by dt. Right? Take this 2 out. Keep it in the denominator. It comes out to be plus d of O2 divided by dt. It comes out to be minus 1 divided by 2 d of H2O2 divided by dt. Perfect. So it will become minus 1 by 2 d of H2O2, change in the concentration of H2O2, which is basically final concentration of H2O2 minus initial concentration of H2O2 divided by time interval is simply 15 seconds, right? So solve this term, right? Whatever value comes out from over here, it comes out to be in moles per liter per second. And this term is basically your rate of appearance of O2. You call this term as the rate of appearance of what? Rate of appearance of O2, which you were supposed to calculate. I'm sure it's clear to everyone, right? Okay, you want me to go a bit slow? Is that? You want me to go a bit slow? Perfect. Let's move on to the next one. Look at this particular equation. We need to calculate rate of reaction in the time interval 5 to 15 seconds. In this time interval, we are supposed to calculate rate of reaction, right? In this time interval, 5 to 15 seconds, we are supposed to calculate rate of reaction. Now, first of all, the graph which is given to us, as I see this graph, the concentration of reactant, the concentration is decreasing with time. Concentration is decreasing time, right? And we know concentration of reactant decrease with time. So this is the graph which is valid for reactant basically. And what is my reactant over here? NH3. So this is the graph which is valid for NH3, right? So I will be calculating rate of reaction with respect to NH3, right? I'll be using the minus sign, 1 by stoichiometric coefficient, change in the concentration of NH3, right? Change in the concentration of NH3. Divide by time interval delta T. It comes out to be minus 1 by 2. Change in the concentration of NH3, which is the final concentration of NH3, which is 0.2, minus the initial concentration of NH3, which is 0.6, divided by time interval is 5 to 15, that means 10 seconds, right? Just solve this term, get the answer in moles per liter per second. That's all. Simple and basic equation, right? Perfect. Done with this? Perfect, guys. Moving on to one more. For the following reaction, we are given the reaction and some of the parameters are given to us. We need to get the relation between K1, K2 and K3. Have a look exactly how am I going to solve this. This is the reaction that's given to me. Let me write its rate in the differential form. I'll be writing it with respect to N2. I'll be starting with minus sign. Change in the concentration of N2O5 divided by dt is equal. With respect to NO2, I'll be using plus sign. 1 divided by stoichiometric coefficient. It's d of NO2 divided by dt, right? Now with respect to O2, plus sign, 1 by stoichiometric coefficient. 1 by stoichiometric coefficient. 2 comes up. It's going to be d of O2 divided by dt. This is something which you can easily write, I'm sure. Right? Now we will have a look. Minus d of N2O5 by dt. Minus d of N2O5 by dt. It's given to me as per the equation, which is equal to K1 multiplied by concentration of N2O5, which is equal plus 1 by 2. D of NO2 by dt. D of NO2 by dt. It's given to me as K2 multiplied by concentration of N2O5, which is equal plus 2 times d of O2 divided by dt. D of O2 by dt. It's given to me as K3 multiplied by concentration of N2O5, right? Everywhere you can see N2O5. You need to cancel them out. So I'll be getting the value K1 is equal to K2 divided by 2, which is simply going to be equal to 2 times K3, right? It's going to be equal to 2 times K3. Perfect. If you take the LCM of the denominators, LCM of denominators comes out to be 2. So I'm going to multiply everywhere with 2. When I multiply everywhere with 2, the final answer comes out to be 2 times K1 is equal. 2 got cancelled out, is equal to K2 is equal to 4 times K3. This is the final relation between K1, K2 and K3 which you were supposed to calculate, right? Perfect. Right, people? Is it clear to everyone? Let me know in the chats. Let me know in the chats, my dear people, if it's super clear to everyone. And the ones who have not liked the video, please do like the video, share the video with friends, and do subscribe to the channel as well. Yeah? Perfect, guys. Let's have a look now on the another question. For a chemical reaction A gives B, it's a very simple question. The reaction is given to us as A gives B. Its rate constant is given as K, right? Let me assume order of this reaction is equal to N. I'm assuming order of reaction is equal to N, right? It is found that the rate doubles when the concentration of A is increased 4 times. First of all, let me write the rate law. R is equal to rate constant, concentration of A raised to the power order, and order is N. This is equation 1. Now, as per the question, rate doubles. Initially, the rate was R, now it's going to be 2R. Rate doubles when the concentration of A is increased 4 times. Now it's 4 times A raised power N. Let me call this equation 2nd. If I divide these two equations, 2 divided by 1, R and R gets cancelled. So on left hand side you get 2. On right hand side you get 4 raised power N. Right? So when is this equation true? When can be 4 raised power N equal to 2? When N value will come out to be 1 by 2. Right? And what is N? N is nothing. N is the order of the reaction. That's it. Simple and basic. That's something which I was supposed to calculate. I'm sure this is again clear to you. Look at this particular question, guys. This is the similar sort of question, and I want you guys to do this question on your own. It's a similar sort of question. Similar type of question. Right? It's a similar type of question. The reaction is of the order 2nd with respect to a reactant. The reaction is of the order 2nd with respect to reactant. So this is how I'm going to write the rate law then. Right? How is the rate of the reaction affected if the concentration of reactant is reduced to half? When the concentration of reactant becomes 1 by 2, rate will become 1 by 4 because the power over here is 2, right? So you'll say rate is reduced to 1 by 4. What are going to be the units of rate constant? So let me quickly show you what are the general units of rate constant. The general units of rate constant are moles per liter raised power 1 minus n, second inverse, or you can write it like this as well, ATM raised power 1 minus n, second inverse, right? If time is in seconds, then seconds. If time is in minutes, then minutes. If time is in hours, then hours, right? What is this N over here? N stands for order of the reaction. And it's given in the question that the order of reaction is 2. So N value is 2. If N value is 2, you'll be writing something like this. Moles, later inverse, raised power. 1 minus 2 comes out to be minus 1. It's second inverse, right? Or you can write ATM raised power minus 1, and it's going to be second inverse. So this is going to be moles inverse, mole raised power minus 1. It was already liter raised power minus 1. Now there comes minus 1 over here again. So it's second inverse. So final answer of the question comes out to be moles, mole inverse. Just a second. It's going to be mole inverse. It's going to be liter raised power 1. And then comes going to be second inverse. This is one of the unit. And this is going to be one more unit. The choice is all yours. You need to look at the options. What will be the options given to you as per the question? I'm sure this is something which you can solve on your own from now onwards, right? Simple and basic question this was. This is one more question, my dear people. Experimental determination of order, right? How do we solve these questions? How do we solve these questions? First of all, I'm going to show you the general method of solving these questions, right? Let's have a look. The reaction that's given to me, let's write the rate law for this particular reaction. It's going to be equal rate constant multiplied by concentration of NO raised power X, concentration of H2 raised power Y. This is the rate of this is the rate law which you have written for the given reaction. Number 1. Number 2. As per the experiment number 1, the rate of the reaction comes out to be 3 into 10 raised power minus 5 is equal to K. I'm writing as such. Concentration of NO in experiment number 1, that's 5 into 10 raised power minus 3 raised to the power X. Concentration of H2 in the first experiment, 2.5 into 10 raised power minus 3. 2.5 into 10 raised power minus 3 raised power Y. This is the first equation which you have made over here, right? The second equation, put all the parameters of the second experiment into this rate law. So as per the experiment number 2, rate is 9 into 10 raised power minus 5. It is 9 into 10 raised power minus 5 is equal to K. Concentration of NO in the second experiment, it's 15 into 10 raised to the power minus 3 raised power X. Concentration of H2 in the second experiment, 2.5 into 10 raised power minus 3. 2.5 into 10 raised power minus 3 raised power Y. This is the second equation. Well, if you talk about the third equation, have a look. Third equation says rate of the reaction is 36 into 10 raised power minus 5. 36 into 10 raised power minus 5 is equal to rate constant K. Concentration of NO in the third experiment, 15 into 10 raised to the power minus 3. It's 15 into 10 raised to the power minus 3 raised to the power x multiplied by H2 key concentration in the third experiment. 10 into 10 raised to the power minus 3. 10 into 10 raised to the power minus 3 raised to the power y. So you basically got 3 equations. And out of these 3 equations, you are supposed to calculate x and y basically. So what you'll be doing, I would want you guys to divide the first 2 equations, second by first. When you divide second with first, on the left hand side, this term gets cancelled. 9 by 3 comes out to be 3 on the left hand side. On the right hand side, this whole term got cancelled out. This term gets cancelled out. It's 15 divided by 5, that is 3. So it comes out to be 3 raised to the power x. So when is this equation possible? This is only possible when the value of x comes out to be 1. So you got the value of x. Well, after getting the value of x, you need to get the value of y as well. So divide third with second. Divide these 2 equations, third and second. When you divide third and second, this term got cancelled. 36 by 9 is 4. So on left hand side, you are writing 4. On the right hand side, this term gets cancelled. 10 divided by 2.5 comes out to be 4. And this term gets cancelled. So it becomes 4 raised to the power y. When is this equation possible? This is only possible when the value of y comes out to be 1. So you got the x, you got the y, right? X is something which we call as order of the reaction with respect to NO. Y is called as order of reaction with respect to H2. So you can write the overall order of the reaction as well. Overall order of the reaction, I must say, it's equal to x plus y. So 1 plus 1 comes out to be 2. So overall order of the reaction is 2, which I was supposed to calculate. Perfect. Let me know in the chats. Perfect, people. I'm sure you can easily solve these sort of questions from now onwards, right? This is the question as far as your zero order reactions are concerned. Let's have a look. Look at this particular question carefully. It's simple. A rate constant for the reaction, for the zero order reaction. Rate constant for the zero order reaction is given. How long will it take for the initial concentration of A to fall from 0.1 to 0.075? Let's assume this is the reaction A gives B. Its rate constant is K, which is given to me. And this reaction is basically a zero order reaction as per the question. Let's say at time t is equal to 0, the initial concentration of reactant is A naught. This is going to be 0, right? And initially, as per the question, the initial concentration of reactant, which we represent with A naught, it's given to us as 0.1 molar, right? Let's say at time t, the concentration of reactant left, which we represent with AT, that is 0.075 molar, right? Initially, the concentration of reactant was 0.1 molar. So after some time, the concentration of reactant is becoming 0.075. How long will it take for the concentration of reactant to fall from 0.1 to 0.075? So I need to get the value of T, right? I need to get the value of T. Since it's the zero order reaction, so I'll be using the zero order integrated rate equation. AT is equal to A naught minus KT. So from here you can calculate T, and T comes out to be A naught minus AT divided by K. Well, A naught as per the question is given to me as 0.1. AT is 0.075 divided by K. K value, that's rate constant, that's 0.003, right? Solve it, get the value of T in seconds, right? So this is the time. Whatever value you get from here, that is going to be the time in which the concentration of reactant falls from 0.1 to 0.075 molar. I'm sure it's again clear to everyone, right? Perfect, people. So the final answer of this particular question will be 8.33 seconds. It's going to be 8.33 seconds, yeah? Perfect. Moving on to one more. This is something which I'm giving you as the homework. This is the similar sort of question, and you guys are going to do it on your own. Only one thing, rate constant is not given to us. So first thing, you'll be calculating the rate constant. Rate constant for the zero order reaction, that is A naught by 2K, right? Sorry. Half-life of the zero order reaction is equal to A naught by 2K. So from that expression, you'll be calculating K. And then you'll be using the integrated rate equation and to get the value of T, which I was supposed to calculate as far as this question is concerned. Similar sort of question, guys. So K value you'll be calculating first of all. After calculating the K value, then you'll be using this expression, get the value of T over here. The similar type of question which I would want you guys to do on your own. Look at this particular question, guys. It belongs to the first order kinetics, right? And for the first order reactions, you all must be familiar with certain important results. Time taken to complete 75% of the first order reaction is always equal to 2 times the half-life. Number one. Number two, time taken to complete 87.5% of the first order reaction is always equal to 3 times the half-life. Number three, time taken to complete 99.9% of the first order reaction is always equal to 10 times the half-life, right? Now look at the parameters which are given to me. Time taken to complete 75% of the reaction is given to me as 100. So this term is given to me as 100 is equal to 2 multiplied by T half. So from this expression, you can calculate T half, which comes out to be 50 minutes. So this is the half-life which you calculated. After getting the half-life, you can easily calculate the time taken to complete 87.5% of the reaction. It is 3 times the half-life. 3 multiplied by 50 comes out to be 150. So 150 minutes is the time taken to complete 87.5% of the reaction. That's all. That's something which you were supposed to calculate. I'm sure you can easily solve it from now onwards, right? Look at this particular question, guys. Well, this is the curve which is valid for the first order reactions, right? Log AT versus T curve is given to me. First of all, as per one of the forms of integrated rate equation for the first order kinetics is concerned, you know, log of AT is equal to log of A naught minus K divided by 2.303 multiplied by T. This is one of the expressions which is valid for the first order reactions. Since you're plotting log of AT along y-axis, you're plotting time along x-axis, so this whole term becomes M, this is minus over here, and this is C. Y is equal to minus mx plus C. It's absolutely a straight line over here. What about slope of this particular curve? If I talk about slope of this particular curve, slope is equal to what? Slope is equal to minus K divided by 2.303. And slope of this curve is tan of theta basically. What is theta? This is theta. Theta is the angle which the curve makes with the positive x-axis in anti-clockwise direction. So tan of theta, I must say it's tan of 135 is equal to minus K divided by 2.303. Tan of 135 is nothing, that's minus 1 is equal to minus K divided by 2.303. So from here, you can calculate the rate constant, which is 2.303. And since if the values were given in seconds, then write it as second inverse. If the values were given in minutes in the question, then write it as minute inverse, right? Perfect. This is how you're going to solve this sort of question from now onwards. I'm sure you got it right. Got it, people? Perfect. Let's move on to one more type of equation. This is one more type of equation, my dear people. You can expect this sort of equation again and see how I'm going to solve this. As per the equation is concerned, we are given with the elementary reaction. Elementary reaction is the one which gets complete in a single step. This is the elementary reaction that's given to us. Its half-life is given to us, T1 by 2. Its half-life is given to us as 10 minutes, right? 10 minutes. Okay. So before solving the question, let me tell you, for the elementary reaction, order is always equal to molecularity. Molecularity of this reaction is 1. Therefore, the order of the reaction is supposed to be 1. So the given reaction that's given to me, it follows the first order kinetics, right? Because it's a unimolecular reaction. And you know, for the elementary reactions, order is equal to molecularity. So the order of the reaction is going to be 1. Well, after writing the order of the reaction, T half for the first order reaction is nothing, that is 0.693 divided by K is equal to 10. So from here you can calculate K value. It's going to be 0.0693. Now the units are going to be in minute inverse. So you calculate the rate constant. What do we need to calculate as per the question? We need to calculate the time in which the concentration of reactant will be reduced to 10% of its original value. How long will it take for the concentration of reactant to reduce to 10% of its initial value? Let's say at time t is equal to 0, the concentration of reactant was A naught. Now when the reaction proceeds, the concentration of reactant will keep on decreasing. There will be a time when only 10% of the reactant will be left. 10% of reactant means there will be a time when only 10% of reactant will be left. And the left out concentration of reactant is represented by AT. I need to calculate at what time 10% of reactant will be left. At what time 10% of the reactant will be left, right? So 10% of reactant means A naught by 10, right? It means A naught by 10. So basically I need to check at what time the concentration of reactant will reach A naught by 10. Perfect. Now use the integrated equation for the first order kinetics. You can say T is equal to 2.303 divided by K, which is 0.0693, right? It's going to be log of A naught divided by AT. A naught divided by AT is A naught by 10, right? A naught cancel. 10 comes up, log 10 comes out to be 1. And when you solve this value, T value will approximately come out to be 33 minutes. So in 33 minutes, I must say 90% of the reaction will get completed. Or you can say in 33 minutes, 10% of reactant will be left in the container as such after 33 minutes, right? So after 33 minutes, 10% of the reactant will be left in the container as such. Perfect. One more question on your screen, my dear people. How did you find the order of the reaction? Since it was mentioned in the question that the reaction is elementary, and for the elementary reactions, order is always equal to the molecularity. Molecularity of the reaction was 1, therefore its order is also 1. Okay, look at this particular question, my dear people. Again, this simple sort of question. How much reactant will be left after 3.5 minutes? I'm sure every one of you would have come across this relation. AT is equal to A naught divided by 2 raised power n. This is the expression which we use in order to calculate the amount of reactant left after n half-lives. N represents the number of half-lives, which is total time divided by T half. This is the expression which we use when we need to calculate the amount of reactant left after n number of half-lives. Now we will have a look. The graph is given to me between ln of AT versus T. If I talk about this particular angle, it's going to be 135, right? So slope of this particular line, slope of this particular curve is equal to minus k, right? Slope of this particular line, because it is the curve between ln of AT versus T. So slope of this particular curve is equal to minus k. Slope is nothing that is tan of 135. Tan of 135 is minus 1. So minus 1 is equal to minus k. So from this you can calculate the k value as 1, right? And it's going to be minute inverse. So k value you calculated. Well, after calculating the k value, just calculate the half-life, which is ln 2 divided by k. Ln 2 you need to take as 0.7 divided by k is 1. So you got the half-life. Well, after getting the half-lives, let's calculate the number of half-lives n, which is total time 3.5 minutes divided by half-life 0.7. The value comes out to be 5. So you calculate the number of half-lives. After calculating the number of half-lives, I'll be getting the concentration of reactant left after 5 half-lives, right? So it's going to be A naught divided by 32 molar. This is the concentration of reactant left after 5 half-lives, or you can say this is the concentration of reactant left after 3.5 minutes, which I was supposed to calculate as per the question. I'm sure you got to know exactly how to tackle these sort of questions, right? Perfect, Google. One more question, which is something I'm giving you as the homework. This is one more similar sort of question. I would want you guys to do this on your own. Yeah? Perfecto. Let's move on to the questions of the surface chemistry. Let's move on to the questions of surface chemistry. And you guys know from the surface chemistry, majority of the times, only the theoretical questions are asked, right? The first question, look at this, guys. If temperature increases at constant pressure, what happens to the extent of absorption? See, if you talk about the adsorption, it's exothermic. It's exothermic in nature. Therefore, with the increase in temperature, let me tell you, extent of adsorption decreases. Extent of adsorption decreases. So first part of the question is done. On keeping the pressure constant, and when you increase the temperature, since the adsorption is exothermic, if it is exothermic, so due to increase in temperature, as per the Le-Chatelier principle is concerned, I can say the extent of adsorption decreases, number one. Number two, if I keep the temperature constant and increase the pressure, on increasing the pressure, keeping the temperature constant, do remember extent of adsorption increases. With the increase in pressure, adsorption increases. Simple. You guys know it, right? Name the catalyst and promoter used in Haber's process. Let me know. Iron and molybdenum, right? Finely divided iron is used as catalyst and molybdenum is used as the promoter. So this sort of equation you can get in your examination. Write the dispersed phase and dispersion medium of the following. You need to write the dispersed phase and dispersion medium of smoke and milk. And I'm sure you guys know it. Dispersed phase for smoke is solid and dispersion medium for smoke is gas. Similarly, for the milk, dispersed phase is your liquid and your dispersion medium is your water. Right? That's also liquid. Perfect. The first one is solid in air, the second one is liquid in liquid, right? Perfect. Write one difference in each of the following. You need to write one difference between lyophobic and lyophilic, right? Lyophilic, liquid loving, right? Lyophobic, liquid hating, liquid repelling, right? Lyophilic salts are the ones wherein there'll be strong affinity between the dispersed phase and dispersion medium. Lyophobic colloids are the ones in which there'll be very less or no affinity between dispersed phase and dispersion medium, right? Yes. And then solution and colloid, that's something which every one of you will be knowing. What is the difference between solution and colloid? Right? These are the questions, guys, which you have to write basically. Okay? Absolutely, in the solution and colloid, the size of the particles differ. Solution has the particle size is less than 1 nanometer. Perfect? Look at this one. Write one similarity between physisorption and chemisorption. Both increases when you increase the surface area of the adsorbent, right? Both increases when you increase the surface area of adsorbent. So surface area is common in both. In physisorption or chemisorption, which one has got higher enthalpy of adsorption? Enthalpy of adsorption is highest for the chemisorption, because in chemisorption chemical bonds are formed in which more energy is released. So delta H is more negative there, right? Perfect. Chemisorption has higher enthalpy of adsorption, right, as it involves chemical bond formation. Whereas in physisorption, what happens? There is only van der Waals interaction between the adsorbate and adsorbent. One more question on the screen. Give reason why a finely divided substance is more effective as the adsorbent. Because when you divide the adsorbent finely in the powder form, surface area exposed becomes more, and more the surface area exposed, more is going to be the extent of adsorption, right? What happens when we divide a adsorbent into pieces, into small pieces? The exposed surface area increases, due to which adsorption increases. Explain what is observed when the electrolyte NaCl is added to the hydrated ferric oxide salt. Hydrated ferric oxide salt, it is a positively charged salt. So basically, Cl negative, which you are adding basically, Cl negative of this NaCl, right? It coagulates this hydrated ferric oxide positively charged salt, right? Coagulation takes place. Neutralization of charge takes place, right? Precipitation takes place. Perfect. So look at these two statements which I told you. Define the following terms. Brownian moment, this is something which you studied in class 10th, guys, right? And peptidization. Perfect. These are the two questions which can be asked in your examination, and I'm sure you guys must be knowing about them already, right? And I have given their definitions as well. This is the way you guys are going to write it in the examination. Differentiate between adsorption and absorption. This is again the basic question, right? You guys know it. Why are lyophilic colloids more stable than lyophobic, right? This is frequently asked. Why are lyophilic colloids more stable than lyophobic colloids? What is that? What is the reason? What is the reason? Because in lyophilic colloids, more solvation takes place. That is something which is extra in lyophilic. This is because the stability of lyophobic colloids is only due to the presence of charge, right? On the other hand, the stability of lyophilic sol is due to the charge on the colloidal particles as well as solvation of the colloidal particles, right? This is something extra in lyophilic. And these are the differences which I'm sure you guys know. What type of force is responsible for the occurrence of physisorption? Van der Waals force, right? What is aquasol and alkosol? In aquasol, dispersion medium is water. In alkosol, dispersion medium is alcohol. What are dispersed phase and dispersion medium in milk? You guys know it. Give one example of sol and gel, right? Sol, example is paint. Gel, example is butter, right? Perfect, guys. And the third one, what are the dispersed phase and dispersion medium in milk, right? It is basically liquid in liquid. Few minutes back only I've told you. Explain what is observed when a beam of light is passed through a colloidal solution. Dispersion of light takes place. Tyndall effect takes place, right? Tyndall effect happens. Electric current is passed through the colloidal solution. So when electric current is passed in the colloidal solution, the ions, they move towards the oppositely charged electrodes, right? And the process is called as electrophoresis, if you remember. The process is called as electrophoresis. It's a very common question. Absolutely, guys, you could know it. Perfect. That's all from my side in the tonight's session. I would want you guys to follow the session again. Watch the session again. If you'll be having any sort of difficulty in understanding, let me know in the comment section of the video. And do like the video, share the video with friends, and do subscribe to the channel as well, right? Tomorrow I'm going to come up with one more similar sort of session in which I'll be giving you some 30 questions, short questions from your entire syllabus of your CBSE Term 2. Perfect? I'm sure this session was beneficial for all of you. So if you have not liked the video yet, please do like the video, share the video with friends, and do subscribe to the channel as well. Take care. With this, I'm going to take a leave. God bless you all.